Hello everyone, this is Team 15. We chose the topic Strategic Congestion Control, Visualizing NYC subway usage and infrastructure. So we are a team of three, Tautu Nikhil, Tautu Nikita, and Anil Reddy Veerayagari. Next, we move on to the introduction. So we took urban mobility and transportation analytics as our domain. So, this project uses visualization techniques to study and enhance New York City's subway infrastructure and pedestrian data through its analysis of transit data. So, our problem statement is among the world's most heavy duty rail line exists New York City subway system, which suffers from congested travel routes and imbalanced transit system placement. So we want to explore where congestion is the highest and how pedestrian traffic evolves over time and how station infrastructure elements determine how people move in food traffic areas. And next, move on to the methodology. It will be taken over by Nikhil.
Anil
The
will explain the
methodology,
methodology.
the methodology was explained by myself, Anil. We can see in the methodology there are four steps. First, the NYC system dataset and the pedestrian counts dataset, where by using the Python data and clearing and merging with it, we will use the Tableau data visualization because in the Tableau visualization the result will be shown very visualization way that we can understand the result very simple. So we use the Tableau visualization, and by that the HTML website page is embedded and interactive, and dashboard will be publishing. Next, the data abstraction. In the dataset details, it is a type of a dataset. It is in structure. The attributes are subway, where the transit division, line name, station name, entrance type, description, entry, exit only, and vending, staffing, and etc. In pedestrian, there will be data, date, location name, time and date, pedestrian count, and latitudes and longitudes. So the size of the datasets will be subway will be 1867 in the number of rows. Pedestrian also have 11,290 number of rows. And next,
Yeah, so I'm going to say the task abstraction. The target is identify busiest stations and locations. And we are going to examine the historical trends of pedestrian population development. And we're also going to analyze the subway entrance placements requires direct links between the transportation points and the passenger volume levels. And the actions going to be taken are aggregated per station and location. The data displayed is on based on the time, which is AM, PM, and the midday. Both the pedestrian and subway datasets for analyzed to visualization presentation generation. So the tools we have used are Tableau, React.js, and also we use the Vercel app to deploy the React.js app. And we also use the Python to clean the data. So I'm going to show the Python code. We have used the pandas library to load the data set, and we have also used we have used the data frame to clean the column names and then extract the latitude and longitude from the data set. Uh, and then we are going to create the location name. It is just location in the I mean like it is the street name on the data set. So we are going to extract the location name from it. And we are also going to do some data pre-processing in this one. And with one data column, we are going to extract the year, month, and time of day from it. And we are going to save it in the Excel. And now the React app is going to be explained by Anil.
yeah, this is our main homepage of our project. We can see the NYC pedestrian traffic analysis is the main title of our project. in the home base. It is under the scientific data visualization project, and we can see the applications here. The first is a home page, and beside you can see the project overview, methodology, visualization gallery, pedestrian data, subway data, and insights. There are so many types in the pedestrian data and subway data also. And there are the future dashboard. In the future dashboard, we can see the pedestrian traffic overview and subway infrastructure and analysis. And down, we can see the project highlights, where we can highlight the main important things in this project, like data exploration, geographical mapping, and trends analysis. We can see the home page. You have in the project where you can pedestrians and the trafficking of a main important of this homepage. Now, Nikita will be continuing the project.
Coming to the project overview, it's about the exploration of NYC pedestrian traffic patterns and the relationship with subway infrastructure. So it includes our problem statement. It is about the pedestrian traffic patterns across NYC, and also the domain, which focus on urban mobility analysis, which examines the intersection of pedestrian traffic flows and public transportation infrastructure in NYC. And also it shows the data source, which we take the two primary data sets of NYC pedestrian counts across various locations, and the other data set is about NYC subway entrance and infrastructure data. So we have on the right side, it's about the project highlights. So the highlights are the temporal analysis, spatial visualization, trend analysis, and infrastructure analysis. The methodology can be explained by Nikhil.
Coming to the methodology, we already seen in the PPT. This is the methodology of our um, web page, and here is the data abstraction, task abstraction, and the data abstraction includes the type, key attributes, transformation, and the task abstraction includes the target actions and methods. And the implementation tools are for the preprocessing are Python, Pandas, NumPy, which we have seen before. And the visualization, we use Tableau, Tableau Public, and Markbox integration. The Tableau Public is used to generate the links, and the web integration, we have used the React and Tableau API for the React and also the CSS. In the visualization gallery, there are like 14 visualization we have displayed directly connecting to the Tableau public. And these are some of them going to be explained by Anil and Nikita as well.
We can see the top 10 busiest bus stations in the NYC. Yeah, in the top 10, we can see that they are the 34th Street, 23rd, 14th, 59, 86, 50, 125, 42, and etc. We can see the count of the station's name and the station name also. On the 34th, the red one shows the transit division of IRT, and the count of the station name is 11. And in the right side corner, we can see as the station names all will be divided from 1 to 34. Yeah, this is the top 10 bus stations in the NYC. And
Can you please open the subway entrance locations, Nikhil? Yeah, can you please zoom it? So these are the station names, the latitudes and longitudes. Yeah, and the transit division of each stations. So the transit division is indicated by the right side indicated colors, the blue, the yellow, and red. So we can see the subway entrance locations here.
And the pedestrian trend over time, we can see that the pedestrian count on the left side and the date on the right, on the, I mean, like Y column, X column, the date, and the pedestrian count on the Y axis. And it's increasing from the 2007 to 2024. And there's also a drop in the data from 2020. This is maybe due to the COVID-19, maybe the virus. And also like the pedestrian foot traffic density map is also going to be explained by Nikita now.
Yeah, yeah, this is the pedestrian count. So can you please zoom it, Nikhil, so we can have the clear picture. So right side is about the pedestrian count and the colors. So the more greener side, it includes the less pedestrian count, and the red includes the more pedestrian count. So Nikhil, can you go back and show us the pedestrian data and the subway data drop downs?
Uh,
Yeah, the pedestrian data includes the pedestrian growth trends. So it's about the time of day comparison, location versus time of day, and cumulative pedestrian volume over time, and pedestrian data average count by month. And we also have the subway data drop down. So where we have included the subway usage, infrastructure breakdown, and station entrance types. So you can see the down, we have the top 10 busiest stations in NYC, and also they have the number of entrances by transit division. So we have used bar charts to have a clear visualization of the theme.
Here in this dashboard, we can see that New York subway usage overview. And we can also select the BMT to only select the what are the BMT transit division locations in the three of the maps. Like we can play with the IRT, or we can do the IND, whatever the
Yeah,
transit division we want to take.
yeah,
And
as Nikhil said, to have a more clear picture of visualization. So to have to check clearly, so we have included this feature.
uh-huh. And like in the infrastructure breakdown, we have entrance type full type was a part time, and the station versus entrance type heat map. In this also we can play with this around, like change the data type to change both the BMT, the transit division, and also like in the IRT we can change here as well to change um, data types. And uh, like we can use this as a filter to change the data types. And in the station entrance types, there are like three of the them, and like we can show like there's some if we select the BMT, we are going to bet the BMT. If we get the IND, we are going to IN. So this is basically like interactive uh, visualizations. And also like we have traffic insights in here. Like these are the prediction, like four visualization in one dashboard. And we are going to also like can change it using like uh, the May, June, September, October. Like we can see here, like what are the lines here, and also like the pedestrian traffic trend over time. We have already explained this one, and the top 10 pedestrian locations, which locations are more with the which street has it. And like these are the key visualization, the 14 visualizations we have seen. And the insights and analysis are like the temporal, there are more temporal patterns, like evening hours are consistently showing the highest pedestrian traffic volumes. We can see that in the um, we can see this in the here, like in the PM there are more people of the pedestrians are going near the subway stations. So this is a key analysis from the data set. And also like the trend analysis are that it shows the consistent patterns over year over year with the seasonal variations. And the spatial distribution, like Manhattan shows significantly higher pedestrian density compared to the other boroughs. and the infrastructure relationship, like the IIT division showed the highest number of entrances correlation with some of the busiest pedestrian areas. And also, like these are the stages, like understanding the data set and deep analysis and correlations and insights and implications. So we are going to implement future like the predictive modeling, like what are we going to change, and additional data integration, like the New York has like weather data and some of the other data as well. We can combine them as well, and like we can also use the real-time analysis, like what are we going to expect um in the traffic or in the congestion over the rules. So this is our project. Thank you so much.
Thank you.
Thank you.